Hey everybody, welcome back to chemistry, and now I want to go over a particular Achieve problem. So this is on Achieve assignment 6. It's question 4. So if I can blow up the slide, it reads as follows. If the caffeine concentration in a particular brand of soda is 2.35 milligrams per ounce, drinking how many cans of soda would be lethal? Assume that 10.0 grams of caffeine is a lethal dose, and there are 12 ounces in a can. Okay, so reduce the slide, please. So this is not a bad problem to solve. And so I guess the way I might go about this is to first ask myself, what are we trying to find in this problem? And so if you read the problem carefully, it says, how many cans of soda will be lethal? So in the end, we're trying to figure out the number of cans that you would need to drink that would kill you. Okay, now let's look at some of the additional information that we have in the problem. And so one piece of information that we have is that there are 2.35 milligrams of caffeine per 1 ounce of soda. So we have that information. We know that the dose of caffeine that is lethal is 10.0 grams. And so I'm going to say 10.0 grams, I'm going to write CAF for caffeine, so that's the lethal dose. And then the other thing that we have is it tells you, if you look carefully, the number of ounces of soda that are in a can, and it says that there are 12 ounces in a can. So let's think about what that means. So if we have 12 ounces in a can, you could write it like this: 12 ounces is equal to 1 can. But I'm hoping you know by now, you can convert this equality to fractions, and so I'm just going to write one of the fractions there. So I'm going to write 12 ounces over 1 can. Okay, so those pieces of information will be helpful to solve the problem. Okay, so we know where we need to end, and so you might ask, well, which of these pieces of information do we want to begin with? And in my opinion, you can start with any piece of information, but for me, a strategy is apparent if you start with 10 grams of caffeine. So let me explain the strategy here. So we have 10.0 grams of caffeine, and what we're trying to figure out is how many cans of soda is necessary to get 10 grams of caffeine. And so one of the things you might notice here, we have a conversion between milligrams of caffeine and ounces of soda. So I think I'm going to have to first convert grams of caffeine to milligrams of caffeine like this. And then once I'm at milligrams of caffeine, I can use this fraction to convert to ounces of soda. And then let's see where we need to go from there. We need to go from ounces of soda to cans. And so we are told that for every can, it has 12 ounces of soda. So the last conversion will be here. So let me go ahead and set up this problem and try to solve it. So again, we're starting out with 10.0 grams of caffeine. So the first step is we want to convert this to milligrams. And so what we need is we need grams in the denominator and milligrams in the numerator for things to cancel out. So 1 milligram of caffeine, let me just make this a little bit better looking here. 1 milligram of caffeine is equal to 1 times 10 to the negative 3 grams of caffeine. And so you can see at this point that we have grams of caffeine that cancels out. Okay, so what's the next step? The next step is to get this into ounces of soda. And so you're given that conversion. You have 2.35 milligrams of caffeine per ounce of soda. So to get milligrams of caffeine to cancel, what I'm going to do is I'm going to put 2.35 milligrams of caffeine here, and then I'll put per ounce, so that's 1 ounce of soda there. And then the final, well, first let's check things. Milligrams caffeine cancels out. The final step is to get ounces into cans. And so here we know that there's 12 ounces of soda in a can, so it's 1 can over 12 ounces. Okay, so ounces cancels out, and so what we should do is we should get an answer in cans. And so if you do the math, which in my opinion is 10 divided by 1 times 10 to the negative 3, divided by 2.35, divided by 12. The number I got earlier was 354.6099291 cans. And so what you have to do is answer this and achieve in the correct number of significant figures. So let's figure that out. So here I see 3 significant figures. 1 in 1 milligrams is an exact number. 1 times 10 to the negative 3 is also an exact number. 1 an ounce is an exact number. 2.35 is estimated, so that's 3 sig figs. And then both the 1 and the 12, I think they're asking you to assume that both of these numbers are exact numbers. And so we want this, it looks like rounded to 3 significant figures. So what I got is 355 cans of soda will give you enough caffeine to kill you. So thank you for listening to that, and we'll see you next time.